Hello. Today we will run an example on Bluetooth connectivity with our STM32CubeIDE program, and we will connect our Cortex M4 processor to our Bluetooth device, and we will run an example. So the first things first, we will start up our STM32CubeIDE as shown. And I'll let you start up that first and create a new project from up here, a new STM32 project. And it's going to do some initializations. The first thing that you have to do is, of course, select your device. I have my favorites over here, so I select mine and give a name. I will call it Bluetooth. You can call it whatever you like. Let the IOC file create it first. We wait a couple minutes, and then it is started. As you see, we have our interface is seen on the right. The first thing that we have to do is we have to come into System Core and select sys from here, and sys has to have this debug enabled through serial wire. So I select serial wire for debugging. And down here in the connectivity part, I have to select my UARTs. So I'm going to be working with two UARTs. One of them is UART2, and that UART2 is going to be my connection to a terminal. I select that, I enable it through asynchronous, and as you see, these two connections are seen. These are the PA2, PA3 connections to our device for UART connection, so we can get some values printed out on our terminal. We don't have any NVIC settings, we don't have an interrupt enabled for this. We have GPIO, of course, by default PA2, PA3 is seen, and one thing we have to select is the baud rate. We can leave the baud rate at 38,400, that's fine. When you come to USAR3, you're going to enable again the asynchronous. Come down here, set the parameter to 9600 baud rate, because my device works with 9600 baud rate. We have some GPIO. We need to connect some of our pin connections. PB10 and PB11 are by default, as you see over here. You can leave them as is, and then you can make those connections on your device to the Bluetooth device. You have to make those hardwired connections. The NVIC settings has to be set here in this time, at this time, for USAR3. So you make all these connections, and so far so good for the USAR3. And then we have to come into GPIO, and we have to select some devices, some output pins that I will connect to test my outputs. So I selected two of those pins. I call them PB1 and PB2. So I come here, I change them to PB1 and PB2. Okay, so come here and select PB1, from the right hand side. PB1 is going to be my GPIO output, and PB2 is going to be my GPIO output as well. So I have these two outputs, as you see here, defined as from the PB output. So they'll be shown on this GPIO, as you see, and they're going to be outputs as it's indicated in this listing. Now what I do is I click on this button over here, and this generates the code that is necessary to run my initial parameters onto the main.c. So it creates a main.c with all these initializations that I have completed. So I wait until that is completed. What I need to do is I'm going to go from top to bottom to make sure that everything's set up for me. So I have my UART is already defined. I have two UARTs. I need a few lines in between user code begin PV and user code end PV here. So as you see, you need to type in these lines yourself. So that's just an initialization line, things like that. And then following that, I need to add a user code in begin 0 and user code end 0 into this line, a character string which is going to be empty for the time being. So that's going to be an input value from the external device. Okay, and following that, I have a while one statement which is going to be empty. One thing I need to add towards the end of the line, towards the end of the code, in between the user code begin 4 and user code end 4. So just find these two lines, and in between those two I'm going to have to add an extra function which is going to be a callback function for my UART. Now depending on that UART, so I have multiple UARTs, but I can detect what UART that is. So in my case that is USART3, which is Bluetooth module. If it's the Bluetooth module, and if I have received a 71 decimal from that, which is going to be a G letter in decimal, and if it's a G letter in decimal, I'm going to flip this bit, which is GPIO-B, which I just created as an output device, output pin for me, and I'm going to also flip GPIO pin 5. Same thing goes for the other one. So if it's not G, if it is R, then I'm going to flip again my green LED, which is built onto the board, and I'm going to also flip GPIO pin 2, which is another pin that is going to be the red button, red LED for me. Okay, so these are actually button. I have to change them to LED. Actually, they are misleading. Red LED, green LED. Okay. So you just have to type in those lines in between. Just stop the video here, and then you can probably look at it, and then you can try to type it. Alright, so that's all. Then I have completed my program so far. I have a callback point for my UART, and that is the key point actually. So this part is very critical. Apart from that, it's pretty much straightforward. So at this moment, I save this and compile it. Build the project. Check out the console and the error messages possible. There are some problems as you see here, so I use some string operations to determine the number of characters that has been entered. That is going to be the string length. It has to be dynamic, so and the string length procedure is defined as string.h. So I need to add that into the include file. Just come here and I have to add that as an include. String.h is needed. So that's it. Save it again, compile again, build the project again, and fortunately I don't have any more errors or warnings, so I upload this to my device through run. Okay. Yes. At this moment I noticed something. I haven't enabled USART PC5. Sorry, the output device PC5, so I'm going to be enabling that as well as a GPIO output, because that's going to be part of our blinking at the output for the LED. I also add that to the code. And one more thing that we haven't done is we have to add in between, let's go up here, in between user code begin 2 and user code end 2, we have to start the interrupt services for USART manually. So I have to be writing here how UART receive IT line. If you don't do that, the UART won't be able to start by itself. So you have to make sure that that line is there. So you have to write this manually yourself. It's not going to be written by this software. So you have to do it yourself. Now I do another compilation again. Make sure it goes through. Yes, I run the code. Okay. Now a couple of things I use for the terminal Hercules program for terminal connection. So I set it up in the serial part. In COM6, my device is connected to COM6. You can also find your device where it is located by looking at the devices where it is connected. If you come here, down here, and type device manager, all those devices that are in your computer system are going to be displayed, and through here you can find under the ports COM port LPT. As you see here, COM6 is the STM microelectronics ST-Link virtual COM port. So COM6 is my connection point. So I open that to let any communication to go through. I have to start up a Bluetooth communication software that is going to be, for my case, I chose Bluetooth Serial Terminal program, and as you see, it is right here. I have to find my device. HC05 is my Bluetooth device that I connect to. So I connect. Once the connection has been established, you don't see any indicators, but you just see a disconnect. So that means you're connected. Now at this moment, your program can go. As you type R, you will see the LED flipping. So I'll show you that. Press G, the G LED will be turned on, and so forth. Okay, so that is how it goes. Let me show you. Let me first show you the connections. So from right hand side, you have some wires coming in here into my Bluetooth device, and those are going to my TXRX connections. So that's how I set up my TXRX. And you see that black and white connectors, that they go into my LEDs. So I have two LED here connected. One of them is red, the other one is green. And when I click R, for instance, the red one is going to be flipped. Okay, as you see, it's flipped. If I press G, then I see that the green LED is turned on. I can also monitor the same thing on my screen. I have my Hercules terminal is just indicating the status of the LEDs. Once I press the buttons, they will print out some stuff to indicate that some of these LEDs are turned on or off. They are just toggled. So that's basically it. Alright, so that's about it, about the Bluetooth connectivity. So good luck with your own examples. See you later. Bye bye.